All right, guys, so it looks like this virtual learning thing might continue for a while. We're doing 5.3 here, but before I started, I wanted to let you know if you do have access to a printer, these study guides are already posted on Google Classroom for you to print out. Otherwise, it's totally fine for you to still be writing your notes on a separate sheet of paper. Remember, you can pause these videos to allow yourself some more time to write things down. You're definitely going to want these notes when you take your test and your final exam coming up soon. So don't skip the notes because you don't have your study guide. You can definitely take it on your own sheet of paper on any notebook that you might have. So 5.3 here, we're actually going to talk about a simpler way that we can divide two polynomials, and that is called synthetic division. So the first thing we have here is actually just a review of what we learned about in the last section, and that is how to do long division with polynomials. And so with long division and polynomials, we always wrote our polynomials in descending order of their powers. So that was called standard form. So descending order. I would actually just say write it in standard form. You should be familiar with what standard form is of a polynomial. So if you just write standard form for step 1, then that should hopefully make sense. Step 2, if there's any missing terms, like if there's no x squared term, we have to make sure that we have a 0 in there. For our long division, that's still going to be true of synthetic division. We always put the entire dividend polynomial inside the division bracket, which I think in elementary school they call it a house. And then, of course, the divisor goes outside that bracket. And then, of course, you just divide the polynomials the same way you would do long division and when you're dividing two big numbers. It's the same process. It just looks a little bit different because it's a polynomial. And then, of course, you stop when you get a remainder. And if the remainder is 0, then you have no remainder. So here's an example of a long division problem. We did lots of these in the last section. If you didn't watch that video, make sure you go back and watch that one first. So again, underneath of our division bracket, we have the dividend, and outside dividend, yeah, okay. And outside of the division bracket, we have what we call the divisor. When we divide two things, the answer is called the quotient. And anything that we can't divide nicely into our divisor is called a remainder. So again, that's all just some review. You can pause that and write that down if you want to. So on this one, we're just going to talk about how we can check our work. So if I go ahead and I divide x squared plus 3x plus 2, and I divide it by this x plus 1, and I get this answer here, how can I double check to make sure that that is right? So it's just like with numbers. If I did like 15 divided by 5 equals, and we decided that that was 3, right? How would I check that work? Well, we would go backwards. We'd say 3 times 5 equals 15. We can do the exact same thing with polynomials. If you divide two polynomials and get an answer, I can check that answer by going backwards. I can do x plus 2 times, and we don't really use x's for times in algebra, times x plus 1 should equal the original dividend, x squared plus 3x plus 2. So to check that, I can multiply these two binomials using any of the three methods from that last section that we did. I could use the distributive property, I could use the FOIL method, or I could box it up. Let's go ahead and just do boxing it up, just so that we can review what that was. This is the most organized way to multiply two polynomials. And since these are binomials, it definitely would be simple enough to use the FOIL method. But with larger polynomials, we really want to make sure that we're super familiar with this box it method because it organizes our process a lot better. So we're multiplying x plus 1 by x plus 2. So when I fill this in, just like we would any other times table, we end up with x squared here, x, 2x, and 2. So I combine my like terms. I see some like terms right here. 2x and x is 3x. When I combine those, we get x squared plus 3x plus 2, which is exactly what we wanted. So we went back, we checked our work for that division problem to make sure we had the correct quotient, and we do. So this is just to remind you that that's how we would check our work after you find the answer to a division problem. All right, so let's talk about this new method called synthetic division. So synthetic division is another way that we can divide two polynomials, and it's actually it's a simplified version of the process. So when we do this, we still want to start out with our polynomials being in standard form, meaning they're in descending order by degree. Standard form. Okay, and if there's any missing terms, we still have to put a 0 in for those, just like we do in long division. Otherwise, it's not going to line up correctly, and you're definitely going to get a wrong answer. Then we put the coefficients of the dividend polynomial inside the, zoom out, come on. There we go, the division bracket, and I'll show you what that looks like. And we put the negative of the constant term of the divisor factor outside the bracket to the left. So I'm going to stop right there and show you what that looks like. I believe we have an example down. I'll write my own example. So if I wanted to take and divide, let's just use what we had above actually. That example we had above was x squared plus 3x plus 2 divided by x plus 1. Okay, and we already have an answer there. So let me just show you how I would set up this division problem in using the synthetic method. So we're going to put a division bracket here. And under my division bracket, I'm only going to put the coefficients of my dividend. Remember, this here is my dividend. It's what we are dividing. So my coefficients are 1, 3, and 2. 1, 3, and 2. And outside of my division bracket, I put the negative of my constant in my divisor. Remember, this is my divisor. And the constant of my divisor here is a positive 1. So we're going to change the sign on that, and instead of putting a positive 1, I'm going to put a negative 1 right here. So that's set up. Let's look at the next step. The next step is to drop the first coefficient. That's going to be the first part of our answer. We just drop it down. And then we're going to multiply that number that we dropped down by, let me zoom out so you can see the instructions, by the divisor and place the result in the next open space below the dividend. Then we add vertically to get the bottom number, and then we repeat. So this is kind of our process here. We're going to multiply, add, multiply, add, multiply, add until we get our answer. The very last number on the bottom is the remainder. If it's 0, of course, that would mean that you have no remainder. So let's go ahead and do this process now, and we'll do lots of examples. So here's my division problem all set up. And the first thing that we're going to do now is drop down this first coefficient. Then we're going to do the process, multiply, add, multiply, add, multiply, add until we are done. So when we multiply, I'm multiplying this bottom number by the number over here, my divisor, which 1 times negative 1 is negative 1. I put that product in the next spot here. Then I add downwards. Again, we're doing multiply, add, multiply, add, multiply, add. So you multiply by that number -1, then we add down. 3 plus -1 is 2. Then repeat. Multiply this 2 by the number up here. 2 times -1 is -2. Then add. 2 plus -2 is 0. Now we're done. And this last number here is the remainder. Since our remainder is 0, that means that we have no remainder. So the last thing that I need to do here actually is just put my x's back into my equation. We started out with an x squared dividend. So the degree of this dividend is going to reduce by 1. So x squared is going to turn into x to the first power. X to the first power is just x. So these 1 and 2 are the coefficients of my quotient, where this is x to the first power, and this is x to the 0 power, which is nothing. So our answer is just x plus 2, which is exactly what we said it was over here. So to kind of review what we just did, here's another problem. And they don't actually have, do they have it up here? Nope. They don't actually have the problem that we're solving written anywhere, but we should be able to figure that out. Remember the numbers inside my bracket here, the 1, the -2, the 5 that we see inside of our division bracket, those are the coefficients of our dividend. And this number out here is the negative constant term of the divisor. So if I put this back into our division form, this would be, so we have 1, 2, 3 terms. This is our constant term, our x term, our x squared term. So it'd be 1x squared minus 2x plus 5. And our divisor, we can see, since this is a -4, it means our divisor is x plus 4. So in this problem that we have written down here, we are performing this division. Again, the process for this synthetic division, you always drop down your first number, no change, and then you multiply, add down, -2 plus -4 is -6, and then multiply by that -4 again, which gives us +24, add down, 5 plus 24 is 29. And this last number on the end here, I usually put a box around it to remind myself that that last number on the bottom is the remainder. So this one does have a remainder. It's a remainder 29. And our answer at the end, we started out with an x squared problem. So now we have a x to the first power quotient. So our answer is x minus 6, or 1x minus 6. This -6 is the constant term of our quotient, meaning our answer. Quotient is just the answer in a division problem, and 1 is the coefficient of the x term of the quotient. All right, so I think that's it actually for this section. So let's just do more examples with synthetic division. In fact, let's do some examples that we've already done in the last section using long division. All right, so here's actually the 3 problems that we did using long division in 5.1. I recorded 5.1 also for Tuesday's lesson. So if you didn't get that, or if you don't remember, you can go back and rewatch that, but you should already have the notes for these done in long division in 5.1. So if I use synthetic division to solve these 3 problems instead of long division, I should get the exact same answer. But it's actually going to take us less time to do it. So let me show you how this works. So starting with this first one, x minus 3, or sorry, divided into, so 2x squared minus 5x minus 3 divided by x minus 3. So I'm going to write this, set this up with synthetic division. Here's my division bracket, and underneath of my division bracket, I'm going to put the coefficients of my dividend, which are 2, -5, and -3. 2, -5, and -3. And outside of my bracket, I put the negative constant of my divisor. My constant of my divisor here is a -3. When I change the sign, it's going to be a +3. Now that my problem is set up, we can go ahead and do our division. First step is to drop down this first number. Then we're going to multiply, add, multiply, add, multiply, add. We multiply the bottom number by the number in the corner and write our answer here. Then we add down and repeat. Multiply by the number in the corner. Write it here, add down. The last number in my bottom row is my remainder. Since the remainder here is 0, that means we have no remainder. We started out with an x squared problem, so after synthetic division, I am left with an x to the first power problem. My answer is 2x plus 1 with no remainder. If you look back at 5.1, that's the exact same answer we got using long division, but it took us a lot less time and a lot less space on our paper. Let's do the next one. Again, you should already have the work for this done using long division in 5.1. Let's see if we can get the same answer using synthetic division. So to set this up, just like the last one, I'm going to draw my division bracket. And under my division bracket, I'm going to write the coefficients of my dividend, which are 3, -4, and -5. And outside of my division bracket, I'm going to write the negative constant of my divisor. The constant of my divisor here is a +2. So when I change that, the sign of that, I have a -2. Now that our problem is set up, we're just going to follow our process again. We'll drop down the first number, and then multiply, add, multiply, add, multiply, add. We multiply by the number in the corner. Write your answer here. Add down. And then again, multiply this number by the number in the corner. Write the answer here. Add down. The last number on my bottom row is my remainder. This time the remainder is 15. We started out with an x squared problem. If I reduce that degree by 1, this coefficient is the coefficient of x to the first power, or just x. So our answer is 3x minus 10 with a remainder of 15. And I could just put remainder 15, or I could put that remainder as a fraction over our original divisor, x plus 2. Notice this quotient is no longer a polynomial because we have an x in the denominator of our last term. Last problem. Remember, this division problem is written in fractional form. Remember though, fractions are division problems, so there's no difference here. One problem we see in this one though is my dividend, 5x to the 5th power plus 90x squared minus 135x, is missing some terms. There's no x to the 4th power, there's no x to the 3rd power, and there's no constant. So when I set up my equation, I need to make sure that I put zeros in that place, which basically means that we're going to change this problem to this problem. Oops. 5x to the 5th power plus 0x to the 4th power plus 0x to the 3rd power plus 90x squared minus 135x plus 0. over x plus 3. This is the exact same quotient as what's written above. All I did was add some zeros in so that there are no missing terms. It's very important that we do that when we're dividing two polynomials using either long division or synthetic division. If you don't put zeros in for missing terms, you're going to get wrong answers. So let's go ahead and do this problem now. So I'm going to draw my division bracket, and underneath my bracket, I'm going to put the coefficients of my dividend, which are 5, 0, 0, 90, negative 135, and 0. And I'm careful when I do this here to make sure my numbers are spaced far enough apart that I don't get them mixed up. I don't want to accidentally have them overlapping and thinking that it's one number. Now, outside of my division bracket, I have the negative constant of my divisor. My divisor is x plus 3, the constant of which is positive 3. If I change the sign on that, we end up with a negative 3. Now that we have everything set up, I can go ahead and start doing my division. So the first step, as always, is just to drop down our first number. And then we multiply, add, multiply, add, multiply, add until we're done. We always multiply the bottom number by the number in the corner and write the answer in the next spot here. And then we add down. And then again, multiply that by the number in the corner and add down. And then again, multiply by the number in the corner and add down. And again, multiply by the number in the corner, add down, multiply by the number in the corner, add down. And we're done. Our last number here is our remainder. Our remainder in this case is 0, so there isn't one. We started out with x to the 5th power here. So if we reduce that degree by 1, that means the variable on this coefficient has a degree of 4. And as we move to the right, that degree is just going to decrease by 1 each time. So this is 5x to the 4th, negative 15x to the 3rd, a positive 45x squared, and negative 45x to the 1st power, plus 0. So our quotient for this problem is 5x to the 4th power minus 15x cubed plus 45x squared minus 45x.